So today we discuss part C, refraction of light. Okay, here the part C is a sign convention and lens formula. So part C, refraction of light, is sign convention and lens formula. Very important chapter. Okay, here you get some numerical in board exam. Okay, 2 or 3 numerical in every year. Okay, each and every year. So that's a very important chapter, and okay, you do this very carefully in this chapter. So first here we discuss sign convention and measurement of distance. So what is a sign convention actually? So first sign convention is say that is a Cartesian coordinate system. Okay, and okay, so that is the origin point. So the origin point represents 0, 0, and that is a plus x, that is minus x, plus y, that is minus y. Okay, so lens place, so choose a convex lens. Okay, place here. So the optical center at origin. Okay, so the optical center at origin, this is the optical center. Optical center at origin, and that the principal axis. Okay, that principal axis, that is lie on a x plane, sorry, x line. Okay, x dash and x. Okay, so that's very important. So here I put a object in left side. If I put a object here, suppose that is a object in left side, so you see that object place is a minus x direction. Okay, so incident ray, that's the incident ray. Incident ray, okay, fall on this convex lens. See that very carefully. If incident ray fall on a convex lens, that's the incident ray. Okay, and after striking, we get a image actually at that any point. Okay, either here or here. Okay, if you see that very carefully, if object place and their object to optical center, that distance is called u, that is called object distance. So u represent object distance from object to optical center, and then object distance lies on minus x axis. Okay, minus x line. So that's why we choose u in minus. Okay, that's a conventional way. Always we choose object on left side. Okay, that's a basic convention, and you can follow this convention. Okay, so now you see the very carefully incident ray strike there, and if I get a suppose object here, and I get a suppose that is image here. Suppose say that image is here. So if image here, that is a positive y line. Okay, if image here, that is a positive y, so that is a positive plus. If image down here, actually here, that's when image is negative. That's the image concept. That is the image is negative, minus, and from optical center to that image on x line, positive x line, that is called v, that image distance. So v represent image distance. Okay, so object height, if I consider the object height, suppose object height OH, so object height, that is a positive y line, that is a positive y, so that means a positive. And if image distance, that is a length, that is v, that is see that is positive x, that's why this is a positive. If image height, that is called this line. Okay, that is the image height in positive. Okay, positive x and positive y coordinate. So you get a image height dash. If I say that is a dash, that dash will get uh, positive y. So image height is positive y. And if a image place actually inverted, okay, actually image is inverted, so that is image height, that say that image height is not dash, that is a image height, that is a negative. Okay, and the focal length, another important term is called focal length. See very carefully, if that is a convex lens, so focal length obviously the opposite of object, okay, actually behind the lens. Okay, so there is a focal length, and that is point is focus, so that length is focal length FL. And you see the FL focal length, that is also a positive x. Okay, so in case of convex lens, okay, so there is some basic rules, because if you choose a convex lens, suppose the convex lens, that is u is always negative, u is always negative, and v, that is a v that is depending. Okay, if v either positive and is negative, if image in suppose there is a virtual, is virtual, that means image is negative. If image is virtual, image is virtual, okay, so that is v is negative. If image is a real, v is a real, image is real, so that is v is positive, that is image distance. Okay, but if you see the height, okay, you see the very carefully, the height that is a, if inverted, okay, if the image height is inverted, it means suppose that is a real image, okay, real image, that is always inverted here. We know that previous class. Okay, if there is a chart or table, so we see that just only one case we see that the image is virtual, otherwise always image is real and inverted. If real image is real and inverted, so we should say that that is real and inverted. Okay, real and inverted, so that means a positive, because that is a behind the lens. Okay, and the image height is negative. Okay, clear. And focal length for convex lens is that is always positive. Okay, that is focal length always positive. So you see that, and object height. Okay, object height, if object height, we know that is a positive. Okay, always that is object height is always positive. There is a convention rule that object always placed in front of lens, and that is a minus x line. That is why we say that that is image is object height is always positive. Okay, but in case of concave lens, there is a different. But in case of concave lens, you see the very carefully. So place a concave lens, that is the optical center O, and one thing is always true, that is object place in minus x. Okay, so I see that that is a positive y, that is negative y, that is positive x. So object height, that is positive, and u object length, that is a negative. Object height is positive, and that is a length u, that is a negative, because that is a minus x, this line. And if I say that v, very important, the image, That case image is always virtual and upright. Always virtual and upright. If a virtual means same side, okay. So if there is same side, the V is always negative. V is negative, but that image height, that also positive. And the focal length, if I see the focal length, just like here, because that is a divergent length, that is focal focus, that is a focal length FL. Focal length, that's also negative because there is a minus x line. That's the convention actually. That's the convention we follow. Okay, and here is the lens formula. You see, if you choose any of lens, either convex or concave, you should always be negative. You should always be minus. So basic formula is 1 by V minus 1 by U. You should always be a minus. That is equal to the 1 by F. Okay, very important. So focal length of convex lens, focal length of the convex lens, this is that is positive. Okay, so and concave lens, that is a negative. Concave lens, focal length is the negative. Okay, distance of object U in front of lens is always negative. U in both cases, U is negative. The distance of object distance actually negative. The distance of image is positive if the real and from behind the lens. Okay, if the positive image means that is when the real and behind the lens, that is a positive. Otherwise, we are get a negative. And negative if the image is virtual and front of the lens. So here, that is the virtual image, front of lens, that is a negative. Okay, clear the concept, and that's the basic formula. So derivation of this lens formula, okay, that derivation is not included in our class 10 ICSE Physics syllabus, so that's why we ignore that derivation. Okay, so in both cases we found that that is 1 by V minus 1 by U, that is equal to 1 by F. Okay, that clear? Okay. So according to sign convention, convex lens and U is always negative, F is always positive, V is positive for real image and V is negative for virtual image. But in case of concave lens, U, V and F all are in negative. So see that U, V and F means focal length, these three are always negative. Okay, negative, and just choose the numerical value. U is always greater than V. Okay, so here we get some linear magnification. That's the lens formula. Okay, that's very important, lens formula, and we get numerical from this formula, uses of this formula, lens formula, very important, and we solve the solve for numericals. Okay, in next class, or if possible to solve in this class also. The linear magnification, that's important factor. What is the linear magnification? Linear magnification, okay. So what is the linear magnification? So magnification aim, that is we get image height by object height. Okay, that's a linear magnification. So that image height, you see here we get a image height, and here the object height. Okay, that's a linear magnification, and that's also equal to V by U in case of distance. Okay, so similarly, case of derivation is not included in our syllabus, so that's why we exclude that. Don't discuss the derivation. Okay, derivation actually. But here for convex lens, suppose there are two cases, convex lens. See the magnification. There's a convex lens. See that very carefully. In case of this lens, this image is maximum time that is a real, and that is inverted. Okay, right? Real and inverted. Okay, so that's why image height in case of real, so image height is minus and object height is plus. Okay, and there's a v. V is the image distance, you have an object distance. So the image distance is, see that carefully, v that is minus for images virtual, v is plus for real and inverted. So that is v plus, and u is always minus. Is always minus. So v plus, u is always minus, and we cancel these two minus. So we get a image height by object height, that is equal to v by u in case of convex lens. And if you choose a concave lens, you choose the concave lens, okay, so that is the formula is linear magnification, image height by object height, that is v by u. And see the very carefully in sign convention. So concave lens, that is image height and object height is both are positive. Okay, both are positive. Here see that is positive and that is also positive, and image distance and object distance both are also distance and image distance both are in negative. Okay, that's why belong in that direction, front of lens. Okay, so you see that is a minus and minus, so cancel these two minus, we get a image height by object height v by u. Clear? That's a linear magnification for convex lens and linear magnification for concave lens. Okay, and what is the value of u? U is that image object distance. What is the object distance? If you remember that object distance from object to optical center. What is the object distance mean? From object to optical center. And image distance is from image to optical center. Same condition here, from image to optical center. And that object height and image height so lies on x line. Okay, so object height is always plus y, always positive, and as the image height, if image is in plus y, okay, if both are in upright, so if case upright, so there both are image and object both are positive. If is not upright, okay, that is inverted, means in y minus y, that is the inverted, that is the upright, and that is the image inverted, that is the inverted. Okay, that is inverted, that is upright. If inverted, that is a minus y, so that's why inverted height is on a minus y direction, that's why minus. That's a very easy concept. Okay, clear? That's the formula is very important, lens formula and the linear magnification formula for convex and concave lens, and the derivation is excluded in our syllabus, that's why we ignore that. And another topic we discuss, the power of lens, very important. Power of lens, we discuss the power of lens of lens. So what is the power of lens? Okay, the deviation of incident ray or produced by a lens of refraction through it to measure is called power. So actually the power P, that is measured, that is equal to 1 by f. What is the f? Not is a focus, actually that is the FL, focal length. Okay, that focal length, what is the focal length? That's important. Okay, that's not a focus, that is a focal length. Okay, if I put a f or FL, both are in same, that is not a focus. Okay, focus is a point. The point is a dimensionless actually. If a FL, focal length, that is a dimension. Okay, point is a dimensionless. So focal length, that is focus. What is the focal length? Focal length means from focus or principal focus or first focus to optical center. See the very carefully, you always measure from optical center or from any other, from focus, object or image to optical center. So optical center is must here. Either from or to, but optical center is one ending line, either starting or ending. So that is power of lens, that is focus power equal to 1 by Fl. That is the power of lens. So the SI unit is the power of lens, that is equal to power of lens, that is equal to meter to the power minus 1. That is the focal length. And the another important, the unit is called diopter. The symbol is D. Okay. And see how to know that someone say that is positive power, the other say that is the negative power. So what is the positive and negative signifies? If I choose a concave lens, okay, choose a concave lens here and choose a convex lens here. So know that focal length in case of concave lens, focal length is minus. Okay, so that means power equal to 1 by minus Fl. So power equal to, suppose that is a minus 1 by Fl. So that is a negative power. Okay, if focal length that is equal to, suppose say that length is suppose 10 centimeter. So 1 by 10 centimeter. So that means that power is called 10 centimeter converted into meter. So minus 1 by, so that means 10 by 100. Okay, if 10 by 100 converted into meter, so that means 100 by 10, cancel these two, that is minus 10d, 10 diopter. That is the focal length. If a concave lens, that's always the power is, lens power is minus 10d in that case. So lens power is minus in case of concave lens. But in case of convex lens, that's very important. If I choose a convex lens, that means the focal length is positive. Actually, the focal length is here, positive focal length. There is power equal to, suppose 1 by positive 10 centimeter. So that means this 10 centimeter by 100 by 10. That is a plus 10d. P equal to. And see that very carefully. But if you choose a concave lens, so power is negative. Someone say that you put on a specs of positive power lens. So that means that say user lens is convex lens. Okay. Clear? So that is very important. Okay. The power is, lens is dependent. The convex lens is positive and concave lens is negative. Okay. That's very important. Okay. So as the length, or depending on the direction which flows on the direction actual focal length. So that is our basic syllabus. When power is positive, which lens convey the power is positive, and which convey the power is power is negative. Okay, that's, I think that's a clear concept. Okay, there is a positive and there is a negative. And you know that with myopic eye or hypermetropic eye, myopic or myopia, you choose that what type of lens is convex and concave. If suppose you know that concave or convex, and we similarly easily said that that is a positive power or negative power. Okay, that's our topic. Okay, and so we complete the 5C. Okay, chapter part 5C. So next class we will be solving numerical. If you doubt in that, actually there is a mathematical, okay, and conceptual, obviously. If you any doubt in that section, always ask him, let's put a comment. Okay, I will try to give the answer. Okay, so today in the class here. Thank you.